So now in this video we'll do a quick demonstration. This is not a normal way to wire a 555 timer, but of course it is a way. You could wire it because we'll see that it works. So when it gets dark enough, the LED turns on. When it's bright enough, the LED is off. So it's a low light on switch basically, and ultimately when it gets dark enough, the output goes high. When you got enough light, the output is low. Basic 555 timer stuff. So we'll zoom in. Of course, you have to power the 555 timer at all times. And a lot of times you're using 5 volts. So pin number 8 right there is VCC. You go 1, 2, 3, 4, 5, 6, 7, 8 as I showed over there. And pin number 1 is ground. That goes to the negative supply. So that provides powers to the output and monitors the voltages that these other voltages react to. And so the output reacts to the voltages over here based on what's going on in the integrated circuit. It's a better way to say it. So we'll come back to the output here. Again, it doesn't make a direct connection to the positive supply. Not as good as the negative supply by far, but in any case, when the output is high, positive supply, it comes to ground. And I'm sharing the same breadboard row, but anything connected to ground is connected to everything else connected to ground, the negative supply. So I got the resistor instead of the LED at the output. Doesn't matter, but you do need the long lead, the anode, towards where will be more positive when it lights up, and the short lead, the cathode, to where it's more negative when it lights up. So it's sharing that same row as the negative supply right there. So we'll come to number 2 right there. When you give a low input to pin number 2, that's the trigger pin right there, a low input sets the output high. Now, that's what pin number 2 wants it to do. It doesn't always do that. In this video, this circuit, we have a situation where even though pin number 2 is set to ground, which tells it to go high, pin number 4 is a more powerful pin. So we'll come over here and look at this. The resistor there's second row down, going to the negative supply. And it doesn't matter the value of the resistor there. We could put a direct connection to ground if we wanted to. But since I already have a 100K resistor, just grabbed another one. And so, you know, doesn't hurt anything. Big as values you want. For the most part, you'd have to really, really go high so that it doesn't even notice the voltage going through. But 100K is plenty fine. And there I can also like cover this with my finger or, you know, piece of plastic or something. But in any case, that number 2, as I said, is trying to hold the output high. Hopefully you understand everything that we've covered so far. Pin number 4, that's the reset pin. Pin number 4, reset. The most powerful input. So 2 is an input, waiting for a low input. 6 is an input, waiting for a high input. I believe 2 is more powerful, but maybe 6 is more powerful. And then I guess I'm using an NE555, and I believe I read something recently that so I think 2 is more powerful. There's other ones where 6 is more powerful, but I'm pretty sure what the NE555 2 is. But in any case, 4 is more powerful than either of them, and 4 really only fights with 2. So in any case, we get a low enough voltage that triggers pin number 4 right there. And so we have light falling on the light dependent resistor. That is giving us a low enough voltage there that holds the output low, and the LED stays off. Remember, it wants a high output. So we got a low right there. If I went over there, sorry. Got a low right there. LED is off. That's because we have a low enough voltage over here. We, you know, cover this enough, turn out the lights or whatever, turn them down enough anyways, which you can adjust sensitivity with this resistor. Then you can see we got 5 volts at pin 4. That deactivates it. And so tells pin 4 not to do anything, and pin 2 has ground, wants to set the output high, and that's when the red LED will light up. So all this circuitry here wants to keep the LED high, but when we got a low enough voltage due to enough light to pin 4 says nope, it's going low. And as long as pin 4 is satisfied with the low enough voltage, then the output's going to stay low and the LED is going to turn on. So now, since this was a pretty simple circuit, if you're somewhat familiar with 555 timers, I decided we will take a voltage measurement. So this is always a voltage measurement I'm curious about, and this is an NE555 timer. Micro A might be different, even though they mostly work the same from what I've seen so far. maybe this voltage will be a little different. I don't know. And other integrated circuits that are not NE555 or even different manufacturers may be a little bit different. I never really see an exact value given. But there you can see we got a very low voltage. That's forcing the output low. Remember, this LED turns on when the output goes high. And the lamp is at the dimmest setting right now, but I can make it even darker with the light dependent resistor. So I'm not sure when it's going to be on completely, because you can see it's like fading on. So that makes it a little bit different. But it's somewhere in the region of like 0.5 volts right there. Out of 5. I don't know if it'll change if we raise it or not. We can go up, you know, it's probably not good for this circuit, but let's go up to 10 volts. We'll try to keep this as short as possible. And so yeah, we got the 10 volts there, and you know, it's only 220 ohm resistor. 1000 would be better. And yeah, it looks like it was a lower voltage actually. So I think, yeah. So in any case, not gonna worry about that too much. I'll look into that later when I remember this. Okay, so yeah, we'll get back to this. So yeah, 0.08. It's low enough because we got the light dependent resistor and the negative supply. 100,000 ohm resistor trying to pull the voltage up. Light dependent resistors pulling it down when it has less resistance. And so now the resistance is going up. Voltage is going to go up. And somewhere around about 0.5 volts. The LED lights up pretty decently. We will turn the lamp off there. And I'll cover it. Yeah, it's getting even brighter if I cover it right there. So that's kind of interesting as well. So, yeah. In any case, this wasn't on as much as I thought. So that was also kind of interesting. But in case it turned on, which was the main goal. So it's always good to take measurements of every circuit you learn about. So I just picked up some more info, and I'm making a video. I'm not processing as much as I would if I was just playing around. So I'll try to play around with it more later on, and then maybe make updates to what I say about the 555 timer. But for now, that's it. Thanks for watching. Make sure you check out one of the other videos I'm posting on the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.